Awesome. So we'll wait for 5 more minutes for more people to show up, and then we'll get started.
Okay. I will retweet again.
Yeah,
Simply.
I forgot to
Uh,
post in the Twitter, but I guess like not many people show up from Twitter anyway. It's like our usual crowd from the community. So
yeah, that's true. Oh, Emil joined. Hi, Emil.
Hello.
yeah, I think like Shreyan will be joining. He inquired in the general. So 2 more minutes and we'll go.
Okay.
Are you guys seeing the on-chain fees?
Is it high?
It's very high. Yeah.
Ordinals again?
I think it's called something different now, but yeah.
Okay. Yeah, yeah, that's bad.
How can I see it? Like, is there any website where you can see it?
Mempool.info?
Dot space.
Mempool.space, yes. Stratosphere, like I saw that 28165 was still in our edit list. So it's already edited, but I forgot to
Hmm.
upload the video. So I'll do it by tonight.
Yeah. Cool. Why is my internet so slow?
It takes some time, lots of data. Yeah, it opened in mine. 54 sats per VB is no priority. Oh my God. It's above 150 right now, 162. Hmm.
Oh, in the afternoon I saw like 300 also.
Oh my God. Okay. Anybody knows who is doing it?
Nope.
Uh,
The BSV people are gone, right? I don't
yeah,
know
BSB
who's
people
left.
are gone, but like the ordinal crowd is still there, so they might be like trying something new. And
Who's funding them? That is the question.
somehow, like the crypto people always have a lot of money. Yeah, I haven't been into Twitter a lot, so I have missed this. So this is the first time I'm seeing it. Hmm. Incoming transactions spiked up today, and it has been like going up and down for a long time. Okay, ठीक है. Anyway, Bitcoin gonna do Bitcoin's thing. Fee market is working as expected. Good that miners are getting paid. So
Yes, yes.
let's get started. Welcome everybody for another round of Review Club after a bit of pause. And today we are doing PR 24748 test BIP324 functional test for V2 P2P encryption authored by Stratosphere. And today this is like gonna be a two-part review club. So in the first part, we are going to mostly cover the conceptuals of the testing framework. And then on the second part, we will go deeper into the intricacies of BIP324 and what's the test includes. So with that, let's get started. Stratosphere, the stage is yours.
Okay. So as Raj said, like before we go into what the PR actually does, we're going to just understand how the existing functional test framework works, so that in the next club we will know where to put the changes for BIP324 in.
Mhm.
So this part is just focused on how the functional test framework in Bitcoin Core works right now.
Right.
So first question, what is a functional test? How is it different from a unit test?
Okay, I'll give it a shot to start with, then other people can jump in for rest of the questions. So the functional test framework is also known as like integration test in normal software engineering, where we basically test the whole software as a whole. And it differs from unit test in the way, like in unit test we can test individual functions, and in functional test we test the whole software like a black box. So the way functional test work is like it's a Python framework, and using that framework we can spawn like any number of Bitcoin node in reg test, connect them together, create our own custom network topology, and make the node do its node thing, and then observe like how the nodes are behaving together, whether they are like responding to the correct messages, whether they are throwing the right errors. So all these things, so it's kind of like testing from a high level perspective, taking the software as a whole. Does that make sense?
Yeah, good answer.
Thank you.
So, yeah, it is very detailed. So, basically, like what Raj said, unit test would only test a single function in isolation, but a functional test would test the interaction of many functions over a whole system with lots of layers in the stack, network processing. So, you want to
Mhm.
test the whole stack. So, that's where we use functional tests. And in Bitcoin core, like there's this folder test functional. There you have all these functional tests listed.
Right. So
Feature
each are
element.
individual tests that are like doing something specific about it.
Yeah, each are individual. And you can see that all of them have like the same kind of format, how they're written. Like there's a lot of imports. There's some function specific to this test.
Right. Right.
Then how they write the test is by subclassing something called Bitcoin test framework. And this, like we'll check the implementation of this, but then they have this framework has certain functions you have to override. Basically, it's normally always set test params and run test.
Mhm.
And like that's it. You just write your code here and that's your functional test. All of them have the same basic
Right.
structure.
Wasn't there one example test.py or something like that, which kind of like explains this one?
Yeah.
Yes, so
Yes.
it kind of explains how to write a functional test yourself.
Yeah. With lots of comments. You should go through it if you have time.
Right, right. It's a really good written file and easy to read through. Yes.
Yeah.
Okay.
Yeah. Yeah. So so we'll talk a bit more about this Bitcoin test framework. Like this is the base class for all the functional tests. Uh, like we can quickly write a functional test, like just to know how to interact with it. I mean, it's not an actual functional test, but just to know how we
Right.
debug and write Python code. We'll just do it quickly. Uh, okay, just for fun.py. And then you have to make it executable. Yeah, so I'm just going to copy paste and just keep the stuff we need. So you don't need all this. doing all this. So basically, we are just going to import this Bitcoin test framework. We are going to just write whatever we want, and we're going to, just write stuff here. So like you can create 2 nodes, 3 nodes. So there's something called set test params where you can set this. This is all implemented in Bitcoin test framework. So if you look, they
Right.
have
So we are basically overriding this like default parameters, whatever is there.
yeah.
Okay.
So let's like, okay, there are 2 nodes here. So supposing we're doing like a really simple one, which is just going to call get peer info RPC.
Right.
So if you do self-dot node 0, that's you will get the Bitcoin D process for the first node. Like there are 2 nodes here. So this is the first node,
So it's like
the first
almost like
Bitcoin D process.
using a Bitcoin D, and then we can call all the RPC commands on top of that Bitcoin D, right?
Yeah, yeah. So the very cool thing is how we interact with Bitcoin D process is they have created a wrapper class called test node, which does all these weird interactions for you. Like if you the starting of the Bitcoin D process, how Bitcoin D closes, all the log files, all the data directories, everything is managed in this test node class, and it's all done there for you. So if you're just
Okay.
writing a test, you don't actually need to know the internal details of how it works. And it's just so easy. Like you can just do self.node0 and just call the RPC command, and it's going to call the Bitcoin D's RPC command.
Okay.
And let's just print it for now. And how you run it is by just by running the Python script. So it's just
Right.
printed whatever thing.
So it started a Bitcoin D node, and then it made the call, it got the output, all the information that we see in regular get peer info RPC call, and then we just printed it out. Right. Awesome.
Yeah, the interesting thing is there is a peer because like we have 2 nodes, right? So how the functional test framework works is like if you put 2, it will actually connect both nodes.
Okay, by
So
default.
yeah, by default, like if you read the comments, like there is a default behavior wherein the nodes are connected linearly.
Okay.
So if you want to override it, there is more functions which you can. I think it's called like set network. Oh, setup. Yeah, like there are a lot of individual functions which you can override. So here the comments is saying
Right.
override this to make your own topology. So if
Right.
we override it, uh, like this is just going to set up the nodes, and we are not going to connect in it.
Okay.
So there are still 2 nodes. We set up the nodes. Like there's a function which will set up the nodes, like doing all the start methods,
Right.
creating the blockchain. All of those is
Right.
done. But here you just set it up without connecting it. If you don't do this, all the nodes will get automatically connected.
Right. So now it's empty. So because
Now,
like node 1 does not or node 0 does not have any peer connected to it.
yeah.
Makes
If you
sense.
want to connect, there are, I think, there will be more. You see, there's a function connect nodes if you want to connect it.
Right.
So if you want to connect it, you would do self dot connect nodes 0 and 1. And if you again print it, you'll see that this time it prints
Um,
stuff. First time it was empty. Second time
right.
it prints stuff.
Feels so
And
easy.
Yeah. And oh yeah, this is what I actually wanted to show you. Like, if you run it with the debugger, it will stop the program execution there, right?
Right.
So now if you like look for pgrep Bitcoin D, like you'll see that there are two Bitcoin D processes running.
Right.
So those are our two nodes.
Okay.
So you can like, so those are Bitcoin D process, and they are what held by the test node class. You can do weird shit if you want to, like by attaching GDB to these process numbers, set trace points. You can do
Right.
whatever you want.
Right. And
So this,
internally debug Bitcoin D and do stuffs inside and see how the node is behaving and all these stuffs. Yeah.
yeah, that's a very good debugging technique, PDB and this. Then something else which is also commonly used is uh, if there's an assertion failure, like I'm keeping it assert false and I'm running the test, so the test is going to fail.
Mm-hmm.
So if you do combine logs, they have this very good script which will give you all the like it will combine the log files
For
for the
both the nodes.
yeah for the whole test. And
Right.
that's like very useful debugging tool. You can see everything that happened within the test.
Hmm. Okay.
uh, yeah, I'm looking for this. So
Right. So some node received a version message. Status bar, I think we lost your voice. Can anyone else hear me?
We can hear you that.
Yeah, I can hear you. Yeah, we can hear you.
Satisfied left the meeting. I think she might be rejoining. Yeah, she's joined again.
oh weird.
Oh, okay, you got dropped off.
Yeah, where did I get dropped off?
You were showing us the logs and the receive version message, and one process got the version message from the other node. I think that's where we were at.
Okay, okay, cool. Yeah, so that's it. Like this, just I just wanted to mention these are two good debugging techniques. One is uh, doing import IPDB, like
Hmm.
just wherever you want, you can just write it and do it. Other is putting assert false and doing test functional combine logs.py.
Do we need assert false to do the combination of logs, or they are
Uh,
independent of?
so the log files will persist only if an error is thrown. So if your test has some
Oh,
error, it will
okay.
automatically get created. If there's no error, uh, there is code to clean up the log files.
Okay. Okay. So like, okay, you need a failure to happen in order to like persist the logs, and then you can combine the logs and see what happened.
Yeah, this is just if you want to understand how a test actually works.
Hmm.
These are good tools to play with the test.
Mm-hmm. Mm-hmm. Makes sense. Right. So like when the test is running, there is
Yeah,
two Bitcoin D process going on. So these two
yeah.
process will also have their data directory.
Yes, they will all have their data directory.
So I can like also pause the test and look inside those data directory, and there would be a debug log file.
Yes, yes. Oh, when if as long as the test does not end, and if you're
Uh,
at a breakpoint somewhere here,
hmm.
even then the combine logs.py will work.
Oh, okay. So it's only cleared at the end of the test.
Yeah, if the test successfully finishes and then you try, it won't work.
Okay.
Let me
Right.
run it.
Makes sense.
And then okay, this is actually the error for the last failure.
Okay.
I have a doubt. So this get peer info is an RPC, right? So is
Yeah.
every RPC implemented like in what do you call test node.py, or like basically if there's a new RPC, do we have to implement it here as well? I mean, do we have to do something here as well?
Very good question. Yeah. So how RPCs are done is they have a Python thing called getAttr. So if it's unrecognized, it will automatically use this function to make an RPC call.
Okay.
So
So
there's
I mean
something called
like that
RPC.
that means like we don't have to separately implement every new added RPC in the test framework.
No,
Okay.
we don't do it.
Okay. So if it's
Oh,
if
okay.
it's implemented into the software, then it will get recognized and it will execute that RPC, or else it will say like, okay, like method not known or something like that.
Yeah.
Yeah, so every method that's not known will be treated as an RPC and will be called like that, right?
Yeah.
Okay, makes sense. Also,
So
like it is possible to use this Bitcoin test framework as a library for like people to write their own Python code to do stuffs with Bitcoin, basically write their own functional test outside of the Bitcoin core repository.
uh, outside, as in like,
I mean, like I create another folder and create a a Python file from scratch, and I want to import Bitcoin test framework as a library. Can I do
yeah,
that?
yeah. I think some like did you hear about Warnet?
Nope.
Oh, Warnet is that new thing where they implement used Bitcoin's test framework, and they run it on Docker. Okay, I don't remember the exact details on top of my head.
Warnet. Okay.
Yeah, so you can launch a Bitcoin network with specified number of nodes connected to each other according to a network topology from a specification.
Specification. Okay.
And and you run scenarios in this using Bitcoin Core's functional test framework language.
Okay. Right.
So
And
here
they
they've
are also
used something,
Dockerizing it in some ways.
yeah. And here they
Okay.
use Bitcoin frameworks thing as a library or something.
Hmm. Makes sense. This is cool.
Yeah. I want to try it someday when I have time.
Yeah, sounds fun. But then again, like if you are already writing functional test in the framework itself, you can do whatever you want, right? So
Yeah.
I guess you
That's
have
true.
more flexibility here than there.
Yeah.
Okay, cool. That seems like a good intro for the functional test framework. Anybody has any question at this point? Okay,
Yeah,
cool.
I have one question.
Okay, go ahead. Yes.
In the case of functional tests, how are the network port management handled?
That's a good
Yeah.
question. You mean like what is the RPC port? What is the P2P port? That, right?
Yeah, yeah. Or like in the case we are running two nodes, we are trying to run two nodes.
Hmm.
So how are the ports managed?
I think that should be visible in the log file at the start of the log file. The Bitcoin D
Like,
process throws up like what's the port it's using.
yeah. Also, when you did pgrep Bitcoin T, like they show that the first node is running at port 28830 and the second node is running at this port.
Is it the port or a process
Okay.
number?
That should be process number, right?
Oh, that's the
Oh, yeah,
process
yeah.
ID. Yes, that's the process
Yeah,
ID. I
nice.
think the port will be visible in the log file. At the very start of the log file, it will say something like that.
I feel like the port shouldn't be exposed only, no? Can we do it without exposing the ports?
RPC bind to 19658. So yeah, it basically
Oh,
like
it is okay.
adds a random port. Whatever is the available port, it just adds a random one and goes with it. But the port should be exposed in the way like the port is only locally exposable, right? Not in the global network.
Yeah.
Okay.
Okay.
Right. So it basically like assigns a random port for itself.
So, yeah. So what we looked right now is self.node0. That is class test node. That is the, I'm still there, right? Yeah. So that's the thing which manages the Bitcoin D process.
Right.
There's also something called P2P interface. Uh, what that does is it's not an actual node with which runs an actual Bitcoin D process, but it's just a dummy implementation of how a node peer would behave. And it's all just Python code and it can speak the Bitcoin protocol. But it's
Okay.
not an actual Bitcoin D process.
So it's
But
like
using
a ghost that that will reply you back with some Bitcoin messages as if it's a real node, but it's not a real node.
yeah, it just mocks the behavior of a pair.
Okay.
And this is written purely in Python. Like all the stuff, it's everything is written in Python, and you can. So it's a peer, right? So basically, there are two kinds of peers you can have. You can have inbound peers and outbound peers.
Hmm.
So another way of using the test framework is like you can on your Bitcoin D node, you can add a inbound connection. So this is your test node class. So if you click this, it goes to add P2P connection. It's a method in test node. Uh, so it takes P2P interface, that is
Right.
this class which you saw here, and it basically adds that node as an inbound connection.
Okay. So as if that
Till-
node is making a connection to our node.
Yeah,
Okay.
and yeah. So supposing we had just one node, and we are trying to print get peer info. Like we're trying to see if a result will be printed here or not.
Right.
So we need, I need to import this stuff. So you can see that even though it's one node, this one mocks the behavior of a peer. So you're still getting
Right.
some get peer
We are
info
still getting some
things.
data, right? As if there is a node connected.
Yeah,
Right.
it's a
So what
ghost
we
node.
can do with a P2P interface, like now we have a connection with a P2P interface. What can we do with
Yeah,
it?
yeah. So there's much more flexibility here because like because the entire code is written in Python. So if
Okay.
you look here, there are like a lot of stuff you can do on message. So if you receive a particular message, you can like our ghost node, we can test a behavior where if we receive a version message, we don't reply back, and we see if the
Ah,
correct error is thrown.
okay. So we can like overwrite its behavior as, however we want. So if something gets received, the usual workflow is like if I get a version, you return a version acknowledge message. That's how a node would behave. But now we want to do something nasty, is like we send a version, but it doesn't return anything. So we can mock
Yeah.
those behavior.
Yeah.
Okay. And how the
We could
code
do
would look
something.
like?
Yeah, like we could do something. Okay, we're not responding back, but maybe like a very simple print statement.
Okay.
Like, so we're going to again subclass this,
Mm-hmm.
and we just saw those functions here, like a lot of on stuff.
Right.
So for every message, you can override the behavior. So let's just do on version. So okay, it's going to call the actual stuff when you get a version. Means this will call the superclass.
Mm-hmm.
Means the parent class. Means it will call P2P interfaces on version message, and also we wanted to just print.
Okay. So it will handle the version message and then it will print the version message.
Yeah. Yeah. So here, like it's printing the version
Uh,
message.
okay. So this is the version message it received.
Yeah. If this wasn't there, like whatever happens when version message gets handled, like there's no response back on version message. So the test just
Uh,
gets stuck here.
okay. So the now node is like waiting for like the version ACK, but it's
Yeah.
not replying it back. It just printed and paused there.
Yeah, it's just pause. And it will fail
Okay.
after some time.
After, like there is a timeout happening. After some
Yeah.
timeout, it will go like, okay, it didn't responded back, and so the test failed.
Yeah. I think it's a 60 seconds. Wait until, like there are lots of conditions. Wait for the
Hmm.
rack. 60 seconds is the default timeout.
Okay. Makes sense. Nice. So in this way, we can like create bad nodes and
Yeah.
check whether the real node is handling the bad node situation properly.
Yeah.
Cool. That's where the failure happened, I think. It just failed right now.
I just closed the process.
Okay, okay, okay. Cool, cool.
So that was the intro. Like we looked
Okay,
into test node, P2P interface, we saw connect nodes.
nice.
Add P2P connection is how you do inbound. So inbound means like it's inbound to the test node. Like it's into the test node. So that's called
Right.
inbound connection.
So the
Outbound
ghost
means,
node is like making the connection.
yeah, into the test node.
Right.
And outbound connections means the connection comes out from the test node to the
So the test node is
P2P
making the
interface.
connection to the ghost node. So the one was called add P2P connection, and then the another is called add outbound P2P connection. So any
Yeah.
idea why the first one isn't add inbound P2P connection? It like
Initially, we did not, yeah, like initial, like, okay, we'll look in the remaining question, but it's not very straightforward to make an outbound connection to the dummy node in the test framework. We'll see why in the later questions.
okay,
So because of that, this was like pretty recently added. We had to even add a new RPC, a test-only RPC, just to be able to do outbound connections to
okay,
this P2P interface. It was
okay,
added pretty recently, I think in 2020, or like there was an RPC called add connection, which was added just to implement this outbound connection. And it was done
okay,
pretty recently. So that's
okay,
why,
okay, makes sense. Cool. Any more questions on the basics before we move on to our questions? Not anymore. So okay, let's move ahead.
Okay. So first question, what does this PR do at a high level? Why do we need this PR?
Anybody want to go ahead? I can give it a shot, but open stage.
Hint, it's related to test node interaction versus test node P2P interface interaction.
Sorry, it's related to the node to node interaction versus the node to ghost node interaction. Okay.
Yeah,
So
because any
to
changes you make to Bitcoin D will be reflected in test node.
right. Yes.
So we don't need to make any changes.
Right. So like to me on high level the PR looks like it definitely added those functional tests. Like there are two functional tests that was added in this PR, and one was the I forgot early key response and V2V encrypted .py.
Yeah,
So it's basically trying to send the version to data to a node and
yeah,
then trying to see what happens.
yeah,
Okay.
So I think it's because the new transport V2 is implemented in Bitcoin D. The PR got merged, but this P2P interface is not aware of this new standards, right? So that's why we
yeah,
are
exactly.
like, yeah.
Okay.
That's
I
exactly
mean,
what
I
this
mean the
PR did.
ghost node. You mean the ghost node is not aware about these new things?
Yeah.
Okay.
Yeah. So test node can speak BIP324. If anyone isn't familiar with BIP324, it's basically a new protocol using which nodes can communicate via encrypted messages.
Right.
So because the code got merged very recently, so both these test nodes can send encrypted messages to each other, and they will be able to successfully communicate. But if you make an inbound connection or an outbound connection in the test framework using these functions,
Hmm.
the test node can speak BIP324 and send encrypted messages to P2P interface, but P2P interface will not be able to understand it because BIP324 is not implemented yet in
Right.
P2P interface.
So that's what this PR does. Like it implements those things in P2P interface.
Yeah, it implements it in Python in the P2P interface and
Okay.
writes tests.
Write test to check whether it's working as expected or not. Okay. Cool.
Yeah,
That makes it more clear for me.
yeah. Uh, and why do we need this PR? Yeah, these are some of the tests which are written. Like there are assertions to make sure that you're speaking encrypted messages. There are tests to make sure that uh, it's backward compatible. Like you can make sure that traffic shaping works. You can send
Right.
decoy messages. Like
And
lots
we
of stuff
also
you
like
can.
want to do all the flexibility that we can do with P2P interface for this new kind of thing also for this new version 2 stuffs also. Like what happens when something wrong gets sent and those stuffs.
Yeah, it'd be really great to run our entire test suite on V2, the 324, and make sure that there's no failures or
Hmm. I
those
think
kind of
Faisal
stuff.
has a question.
Yeah, go ahead, Faisal.
Yeah, a status for, I mean, when test node 1 tries to communicate with test node 2 in an encrypted manner, is there any checking or any procedure that test node 1 needs to do beforehand to ensure that test node 2 also understands the encrypted language and that it implements BIP 324?
Yeah, so right now, how like the 324 code got merged. So if you're both running the latest Bitcoin release, you'll be able to uh, like understand whether it's a BIP324 node or not. How it works is, if there's no BIP324, if you're talking normal unencrypted connections, the first message I send you will be a version message, and you will respond with a version message, a Verac message, and I will again send you a Verac message, and that's called a version handshake. So if you connect with any peer on the network, the version handshake is how the connection is established, and like that's how you initiate a connection.
Right. So
But
there
if
is
it's
also a version
BIP324,
handshake going on for V2 also.
yeah, like before the version handshake even happens, you do a Diffie-Hellman, a modified kind of Diffie-Hellman
Mm-hmm.
key exchange. So
Right.
you exchange public keys.
Right.
So the thing is, so if I'm sending Faisal via V2, he will not get he will be able to detect that I'm not sending version in plain text, version. He will
Hmm.
instead see some public key data. So his node will be able to understand that I'm talking in V2 because there's no version, and he will
Mm-hmm.
try Diffie-Hellman with me. And if I'm an actual good node, our Diffie-Hellman will succeed, and we will be able to talk on encrypted connection.
Right. So
But if I had sent
This
him version, I would be talking to him in unencrypted manner.
right. But what
so
happens like when I send public key data to a node that does not understand V2?
Disconnect. Like it will not understand. So, there is backward compatibility. So, the new code says that you will first send this. Like supposing you think that node speaks V2, you send your public key to it. The node
Mm-hmm.
doesn't understand and will disconnect. Then you have to reattempt using uh,
V1.
V1 by sending version. So
Okay.
that's specified in the BIP.
Okay. Okay. So it falls back to V1 if the node does not understand V2.
Yeah.
So all nodes that understand V2 will first try and establish an encrypted connection with peer networks. If they fail to do that, and then they'll go back to V1 and exchange plain text.
Yes. So how you know whether a node is speaking V2 is like you saw the version message, right?
Hmm.
Where are the services? Oh,
There
it
n
says level
service equals to
1033.
0, and
Oh, it
then
might.
yeah, it says
Oh,
1033.
okay. That's like maybe in get peer info they actually print the services.
She left. She got dropped off, I think. Status. No?
No, she is still here.
Oh, okay, fine.
Um, Stratosphere, you still here with us? No, I think she's dropped off. Her
Yeah,
screen share
exactly.
is working.
Because I
Uh,
saw text. So should I drop a message that we can't hear you?
Sending it here, also sending in Discord. I think the deep state doesn't want Stratosphere to show us V2. Ah, how do we notify her? Should we comment in her pull request? Okay, I think she's saying something and she doesn't know that we can't hear her.
If the mouse stops, that means she figures it out.
Oh, it
No,
stopped.
I think
Okay.
she
Okay.
she'll read the texts sometime or the other. She'll read the text eventually.
Yeah. Okay. Yeah. She's here.
Why do I keep getting cut off?
Yeah, she's back.
Where did you hear this?
We
Like,
were hearing till like you were finding the service, and we could see in your screen that you have found the service. but we couldn't
Did
hear
you
you.
see me find Did you see me
Yeah.
find P2P V2?
Yes, yes, yes. So that's the service, right?
Yeah, I got P2P V2 because I ran it with minus V2 transport. Did you see
Um,
that?
no, we didn't see that.
Okay, so if I simply run it, I will not get P2P V2. Like it's just network witness network limited.
Okay.
If I run it with V2P transport, it's showing P2P V2 support. It's just a
Ah,
test framework thing. But what I
okay.
was trying to tell is, uh, if like supposing I'm connected to Raj and I sent him a version message, and my version message would contain that I support P2P V2, like that service flag would be enabled in my version message. So when Raj gets my version message, he will be able to know that I support BIP324.
Okay. Okay. So it's not entirely like a hit and trial. It's like if a node is like supporting, it will support it back. Is she dropped again?
No, 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 I'm here, I'm
Oh,
here.
okay, okay, okay. You're here, you're here, you're here. Okay, cool.
Yeah.
Okay, makes sense. So it's kind of like a service that you can identify to other peers that you support this thing.
Yeah, so supposing, okay, so Raj, now you know that I support BIP324 because like you have my address and you have the service P2P V2, like that I am supporting P2P V2. You have that with you. So then you
Hmm.
will store it in your address manager. And the peer-to-peer network also relays addresses. There are three main things it relays: blocks, transactions, and addresses. So when you
Right.
relay my IP addresses, you will give it to other people and tell I speak P2P V2.
Okay, okay. So
So when
like the
my
address
address
manager
reaches them,
also like specifically like keeps a store of all the known V2 addresses that it has found in the network.
all the services.
All the, yeah, okay. Right. So like then eventually everybody will know that you are speaking V2.
Yeah.
Yeah, now I got it, understood it better. Makes more sense. And one small question I had, Sadhusha, is that what data does this BIP specifically encrypt, which was not encrypted earlier, and what data is still accessible? Like, I mean, the IP address of the two nodes, is it are they still accessible to the ISP providers, etc.?
No, it's not. Like this is like a measure against passive attacks. Like so, the messages which are exchanged now are encrypted. So if I send you a message, it will be sent in encrypted format. Only you and I will know what I communicate. Anyone who has access to the wire, who can access the network packets I sent to you, they will see only encrypted contents. So they will not see that I sent you VERSION. They have no idea what I sent you. But you will know that I sent you VERSION version. So
But
that's
they
called
will
passive attacks.
know that I am talking to you or I am talking to this particular IP address, even if they don't know what I'm talking.
Yeah, they will know that we both are talking.
Okay,
But they won't
okay,
know we are talking Bitcoin. It will be
right.
like some random encrypted contents.
But in
But
that
this does
case,
not,
like the
yeah.
the default node is like port is 8332, and then if that's a widely known information, then if two nodes are connected to 8332, then people can infer that they are talking Bitcoin.
Yeah, there was a PR open. It's got merged. I don't remember. It changes the behavior of default port.
Okay,
Uh,
okay, that makes sense because that
it was
becomes an
merged before.
identifying information also.
Yeah,
No, but that can't be used as like a state attack, right? You can't block all collections in 8332. Then we'll just change the port, right?
I mean,
But
then you basically stop internet. But yeah, like, yeah, that
yeah,
cannot
right,
be a widely state attack or something like
right.
that. Yeah.
But otherwise, right now it's unencrypted and that can be easily identified because the version message is same. And yeah, you can easily block all Bitcoin messages.
Right. Right. Yeah. Yeah. I mean, if you are just using random port, then it becomes like garbage data. It's almost like becoming like a Tor thing.
Yeah.
Default. So I'll check for it later.
Okay. Yeah, Praveen, go ahead.
Hi, can you hear me?
Yes, we can.
Yes.
Hi, Stratosphere. Really enjoying your explanations. I completed the script course with Bitshala, but after that my knowledge is pretty much like I can write basic Bitcoin scripts. But now I have a very basic understanding of Python. Like I can write a calculator. But I want to meaningfully learn enough Python to write some tests for the core. So, like, what would be the first step should I take to write tests with the intention of a future contribution to the Bitcoin core? Like, first
Very good
steps. I want.
question.
Yeah.
Thank you.
So you should go through the example test.py, put the trace points which I talked about, import IPDB, ipdb.settrace, step through it, like go line by line, also read the logs, and that will put you in a very good position to understand the tests.
Which file I'm not understanding?
Okay, there's this example test.py.
Okay.
It's in
Okay.
test functional example test.py. I could
Okay.
send you the link in Discord after the
Sure.
call. And also, like this is where I started. It's just code to dig deep into Bitcoin. So it's just simple questions about version handshake. And there she has a question about write a test where a node adds the P2P connections. Like that's kind of what we did. Like
Right.
these are just digging deeper questions.
Right.
If you can understand, like if you can go through example test.py, or if you can take any of these tests and just run the debugger, go step by step, like understand what's happening, that puts you at a very good point, and you can make contributions easily after that. Just tell us on
Right.
Discord. We'll find good first issues for you.
Awesome.
Yay. That's the best place to like start contributing into Bitcoin core also. So basically like functional test, like in the test folder, functional folder, there is example.py that gives you an idea of the basic theories of the test framework. And then you just read through couple of tests, like take any random test and just read through them and see how what they're doing, how they're doing it, how they're connecting, how they're doing various stuffs. Check some wallet test to see how you can use a wallet, create transaction, and all these stuffs. Then play around yourself a bit with your own custom test that we are just doing just for fun.py, and connecting nodes, creating transactions, signing stuffs, broadcasting data. And over time you will get more comfortable. And then there are like a lot of like issues in the GitHub repository specifically for functional tests, and just take any one of them and try to solve it.
Yeah, there's a label called tests. So then you can see all the pull requests open related to tests.
I mean, like another easy start contribution is like just review one of the testing pull request and
Yeah.
see what this guy is doing, see what the new code looks like, review that PR, make some comment, make some suggestions, and like just keep doing this. And then over time you will get more comfortable and will be able to like write your own code also.
Interviewing is a great way to make a PR. Like often the PR gets merged and there's something missing, and then people will tell
Right,
you, open a
right.
PR for it.
Exactly. That's where you get also like PR ideas, like what PR to open. Yeah.
Yeah, good point.
Okay, cool. So how far we were there in our questions? We kind of like
What were we
discussed on the
talking
high
about?
level.
Yeah. Yeah. So the next question, can you trace the functions through which an inbound connection is established in the test framework?
Right. So this
So
is the function that we just saw. right? We just wrote a function called add P2P connection.
This one.
Yes.
It calls the test node object. So you can see it's a member of test node. It adds an inbound connection to the node. It does a lot of stuff. And basically the inbound connection is made in this function. Like it calls peer connect.
Right. And we can use the same function for a real node also, like another test node.
I didn't get you.
Instead of the P2P interface, we can like
Yeah.
also add a inbound connection from another node, right? Another test node. Here, yes.
An inbound connection from not
another
a test
node.
Another subclass of. You can write your own implementation of the ghost node.
Oh, like does it only has to be ghost node? I cannot have an inbound connection from another real node.
Then it's like a manual connection. Then it's kind of like if you want to connect two test nodes, you're using this connect nodes thing.
Oh, okay.
So that actually does an RPC call to add node to establish manual connections.
Acha.
So
And then like the inbound and the outbound is like defined by which node I am calling first, like in the argument list.
Yeah.
Okay.
And also add node, like normally we say add node, like we use add node to do manual connections, right? Not inbound and outbound. Like inbound and outbound usually happens automatically by addresses from our address manager.
Right. Yeah.
Right. We don't usually have to like write commands to start an inbound connection or an outbound
Usually
connection.
like in RPC also, like if you do add node, it will only do an outbound connection from your node to that node.
Yeah, a manual connection, outbound manual connection.
Outbound manual connection, right? Yes. Okay. So our question was, can you trace the function through which the connection gets made? So basically this is where it's happening. So it's calling a peer connect, and peer connect is calling eventually the RPC add node connection, or no?
No, it doesn't. So it's peer connect is implemented in P2P interface class. And this is actually again an implementation of something called P2P connection. So P2P interface is how we interact with the ghost node.
Right.
But this is actually again an implementation of the lowest level class, which will handle sockets, open socket connections, close sockets, TCP connections, reading bytes, all the extreme low level stuff is done by this class called P2P connection.
Okay.
This is something if you're writing tests, you'll never have to come across this. But it's always nice to know how it works.
Right. Okay, so this is like some deep internal.
Yeah, but we need this for the next PR review club because you're going to change this code to talk me through.
Okay.
But normally, yeah, you won't need it. So it calls the peer connect inside P2P connection. It has some peer connect helper where some stuff are set. And then it calls, it does low level Python async IO stuff. So you can see that this is actually an implementation of some Python class called async IO.protocol.
Okay. So async input output protocols for Python.
Yeah.
Okay.
Yeah. So it runs this network event loop. That's like a big smart for loop which will run functions one after the another. So here it will run this create connection function. This is where the actual TCP connection is opened.
Okay. And then it returns some lambda and stuff.
Yeah, a lambda function which would run this task and this connection.
Okay. Pretty deep.
Yeah. So one thing to note here is like we're creating an inbound connection to the test node, right? So the test node is already running at a given port.
Mm-hmm.
And P2P interface just needs to open a connection to a port which is already opened at that point.
Mm-hmm.
So like imagine you have to create an outbound connection. So a test node is already running, but there is no P2P interface open yet at that point. There's no port listening for
Right.
connections.
Yes.
So,
Okay.
so that's why the outbound connection logic is different from inbound connection logic, which
Ah,
is our next
okay.
question.
Okay. So
Hope
why
that
is the
answers.
mechanism to establish an outbound connection in the test framework different? Can you trace the function through which an outbound connection is established in the test framework? So somehow like there will be a imaginary port popped up for P2P interface or something like that. I don't know.
So I
Yeah,
guess like it would call the add node RPC maybe, and then the test node will send some version, and the P2P interface has to give the version back. Is it something like that?
yeah. It's but it's not actually add node. So just so that we can implement this in the test framework with the ghost node, uh, they added this RPC called add connection. You can't use this in production. It's just created just to interact with to create outbound connections in test node.
Okay.
Which year was it? Yeah, in 2020. It opens an outbound connection to a specified node. This RPC is for testing only.
Okay.
So yeah, so everything else is same. So instead of add node, we use that add connection, like I said.
Right. So where is this
So
function? Okay, yes, there's the outbound P2P connection, and what's happening there is like add connection callback, peer accept connection. No, that's a different function, right? Oh no, it's a function inside that function.
yeah, so we will basically call add outbound P2P connection, uh, and what like this is how it
Oh,
talks with P2P interface. There is a
right.
function in P2P interface called peer accept connection. But one of the inputs it takes is a function callback. That
Hmm.
function callback is add connection callback. And what that actually does is uh,
Call add
do the
connection.
RPC call. Yeah.
Okay,
So
so that's the RPC call that we just saw.
yeah, we saw before how we could do RPC calls on a test node. So if it's get peer
Mm-hmm.
info, you're calling it on test node self.node0.
Mm-hmm.
So here, self is the test node. We are inside the test node class. So you can call RPCs on the test node directly.
Right.
Self dot add connection. So,
Right.
so we're passing that result, like that callback, that's as an argument in this function, and lots of other
Okay.
stuff. And if you go, so again, there will be peer accept connection. Like this is inside P2P connection. There will be two of them. Like one of them is in P2P interface. That is what we interact with.
Hmm.
And
And which
where the
has like the internal that is like P2P connection, peer accept connection. That is
yeah,
like
but
the low level stuff.
yeah, what actually happens.
Hmm.
So so yeah, so to do that, if you want to create an outbound connection, again they set stuff using peer connect helper, and now they are using a lambda function to create the a port which is listening using network thread.
Right. So it kind of like spawns up a listening port to which the test node can actually go and connect.
Yeah,
Makes sense. And
and there
this
was
is
also
inside the network thread, and this is like the low level stuffs.
yeah,
Hmm.
implementation of Python.
Hmm. Okay. Okay, I guess like it at least clears as much as possible in my head.
Yeah.
And yeah, there are nuances that needs to be handled when we are doing outbound to a ghost node, because it's not a real node, so it doesn't have anything. So we have to like simulate all those stuffs like as if like it's a new node.
Yeah. And we need to be most concerned with when the version message gets sent. So there is apparently some function called peer connect send version. It makes the version message, because version message is the first message you're going to exchange
Mm-hmm.
on V1. So apparently they make this version message and they set it to on connection send message. I'm trying to look where this message gets sent
Right.
to the other. So so apparently in P2P connection, there's two functions: connection made and this connection lost. These are two methods of the async IO Python class. So all functions will run between connection made and connection lost. So when a connection is successfully established, this function will automatically get called, and if it's set, the version message gets sent here.
Hmm. Okay.
So what we need to think about is when we do BIP324 V2, we need to do the Diffie-Hellman even before this version message gets sent.
Hmm. Okay. Right. So in V2, like there will still be a version message, but this time it will happen after Diffie-Hellman and in an encrypted format.
Yes.
Okay. Makes
Yeah, the next
sense.
question is kind of related. How a P2P message is read, how a P2P message is sent.
Okay. Let's just take a look.
Yeah. Again, more low level stuff. So read is again by data received.
Hmm.
So that's also another async IO function. So whenever data is read from the socket, this function will get called, and
And
you will
yeah,
write stuff into this receiver file.
right. And then it calls on data. And on data, what does on data do? Does a
On
lot of
data is,
things.
yeah, it's our custom
Okay.
implementation to
Okay.
read
So it
the,
reading the magic byte and all these stuffs.
yeah,
Okay, makes sense. So this is where the data read is happening.
yeah. And it's also interesting that like we are not waiting for data to be read, because that would create a lot of latency. Here, when data is read, you get it on the function. So it's like a callback mechanism, not a wait mechanism happening.
Okay. Okay, so you call the function when there is data.
Yeah, when the data is received, this function will get called
Okay.
automatically.
Okay.
Callback style program.
Okay.
So that's how data is received and send message. So again, this is for unencrypted. So in V2, we have to change this to
Hmm.
support V2
Right.
format.
Is that included in the PR also?
Yes,
Okay.
next week.
Hmm.
And this is send message. So this is how messages are sent. So first you will build the message and then you will send it over the socket.
Right.
So build message is again how uh, we are making the unencrypted message.
Right.
It's kind of nice. Like you get to see it in Python. Like there's the message type, then the
Right.
data, and this is the message format. First you have the magic bytes, then the message type, and they have to be
Right.
12 bytes. You're appending rest with zero, then
Right.
you're appending the length. Like you can easily understand it in Python.
Hmm.
This is the double SHA checksum being done.
Right. And then the final message.
Yeah,
Okay. And then we build the message and then we send the message to the socket.
yeah. Again, low level stuff.
Right.
Transport, right?
Maybe right. So, okay, so there is a event loop and then we are like sending this function that may be right.
Yeah.
Makes sense.
So that's
Cool.
how messages are sent. It's all
Okay.
TCP sockets. Yeah.
Right.
Then
What is a version
yeah,
handshake? What tools can we observe to observe different messages that are exchanged? Okay, I think we talked about version message, and
we talked it in the,
yeah.
we talked about it in the very beginning. Anyone wants to recap?
Anyone want to recap their understanding of what is a version message?
What is a version handshake?
What is a version handshake?
So basically, if a test node, I mean, in context of what we covered today, if a test node wants to establish connection with another test node, it needs to know whether uh, I mean, the other test node can receive the data that it wants to share in an encrypted manner. And for that, it needs to know whether it implements the version that is V2. And I mean, from the address manager, also that information can be retrieved. You can get to know which peer nodes support V2. And in accordance with that, if you're certain that you're trying to connect to a node that accepts V2, then you exchange your public key, and then you're good to share data with that node in an encrypted manner.
Right. But I
Yeah.
think it happens for V1 also. Like it's a it's a handshaking thing. Like any kind of like networking protocol will start with a handshake where you kind of like the two nodes introduce each other to them and they say like, hey, I'm this guy, I can do this, and the other guy says like, hey, I'm this, I can do this, and depending on what they each can do, they will like share different information. For example, we saw one thing called services, and so the service flags kind of denotes that what the node can do and what kind of like data the node accepts. So for example, there can be a node that will say like, I will only accept block data from you, nothing else. Then I will know that this node does not accept transaction, this node does not accept address data, it only accepts block data. So my node will only send block data to that node and nothing else. So all this negotiation happens in the version handshake.
I think I answered question 6 because that's specific to V2 handshake, and I think question 5 is
Yes.
general with regards to handshakes.
Right. Yeah.
Yeah, version handshake was more of a general question, but the B2 part was right. Just summarizing the version handshake, this is how you any node will connect to any peer. Like this is the first message you send if you want to connect to a peer. You have to send a version message, and the peer has to respond back with a version and a verac message, and then you send back a verac message. So that whole process you call it a version handshake, and like Raj said, that is how any networking protocol establishes reliable connections. Even TCP has a TCP handshake,
Right.
after which a TCP connection is established. Just like that in Bitcoin, we have this version handshake. And only after this handshake, you can send and accept other messages. And you something else which Faisal mentioned was service advertising. So the version message will contain information about the service bits a peer supports and advertises, and we will know what services the peer supports. Services like P2P, V2, or blocks, like you mentioned. Then
Right.
another thing is like if you look at this version message, there are also other details like what is the current version, what is the time, what else? Yeah, the starting height of the block, like what's the latest block height the other node knows about. So stuff like that too.
Right. So the next part was what tool we can use to observe different messages that are exchanged. Um, I mean, we can do this hacky callbacks for stuff. So there is a easier way to see like what are the messages being exchanged by the node.
Yeah, even get peer info has this thing, right? Like bytes sent per message, bytes received per message. So what was the question? Yeah, so you can see the different messages which were exchanged.
Right,
P filter message 32 bytes, get headers 669 bytes.
right. So get peer info will show those details. Like these are the
Yeah,
messages being sent.
yeah. And we also saw in combine logs how every message, like everything the node talks, you can find it there.
Right. That also like get logged in the debug log, so can be seen over there.
Yeah. Sending version, received version, all those stuff.
Right.
Yeah, the next question.
Briefly explain initial V2 handshake in BIP324 and when it would need to be done so that P2P message exchanges are encrypted. So it's basically like what happens in the V2 case for version handshake. So if I had to guess, so instead of sending a version thing, you send encrypted data, and upon receiving the encrypted data, the node basically tries to decrypt that data, and or no, you don't send encrypted data at the start. You send like some kind of like Diffie-Hellman thing,
Yeah,
right? Some public key stuffs. And so if the node like successfully parses the data and identifies the public key, then it will first negotiate a Diffie-Hellman with the connecting node. And then they will like come up with their common secret and create a session, like a session, right? And then the usual communication flow will start, and then um, you will send version, you will send services, but all in encrypted format. Is that what
yeah,
happens?
yeah. So the initial V2 handshake just refers to the very first part which you talked about, uh, the Diffie-Hellman thing. That's
Right,
so before the version handshake. This like what I meant by initial V2 handshake was before the version handshake, that Diffie-Hellman key exchange which happens.
mm-hmm.
And after that, like both you and I will have the keys with which we can both encrypt and decrypt the messages, and nobody else will know about it.
Right.
And we can send each other encrypted version and Barak, and our version handshake gets done, and then we can send whatever messages we want to each other.
Right. Then it's like the usual flows, and but in encrypted format.
Yeah, everything else is the same. And this is
Right.
how the BIP like this is the picture in the BIP about how the B2 handshake works. So
Right.
there will be an initiator and a responder. Those are two nodes. One of them will have to initiate the V2 connection. So
Right.
this is the modified form of Diffie-Hellman it uses. So it
Mm.
first sends alligator swift bytes. So alligator swift. So you can't just send the public key over the wire, because a public key is an elliptic curve point,
Mm-hmm.
and it will satisfy the equation y square is x cube plus 7 mod p. So
Mm-hmm.
anyone, an ISP or anyone who gets access to this will know that it's a public key and we are doing Diffie-Hellman. So even to hide the
Okay.
fact that we are sending a public key, we use something called an alligator swift encoding. That's an encoding which will make the public key look indistinguishable from uniformly random bytes. So no one knows you're sending public key.
Okay.
So the
Makes sense.
responder, when they get it, they'll be able to decode this encoding to whatever public key if they want.
Right.
So
What
that's
if
the
the
modifier.
attacker also like decode the alligator swift thing because it knows that it's a like you guys are doing BIP324 and it has read the BIP and it knows what's going on,
Yeah,
and tries to like decode the stuff like a
yeah,
regular node.
yeah. Two things. First, the even the possibility that they get the right 64 bytes, like the correct alligator swift bytes is very less because they don't know when the alligator swift is being sent. That's one thing. Second thing is, suppose they even get it and they are able to decode it, the Diffie-Hellman secret which gets established will be different. Like you'll be talking with the other node.
Right.
Like so that's why this cannot protect against active attacks. Like if you're running an actual Bitcoin node, you have the resources to run an actual node. BIP324 doesn't protect you because the attacker can just run a Bitcoin node and speak to you.
Right. Right. Yeah. I mean, the attacker can if somebody wants to attack you actively, they can do a lot of things.
Yeah, but they need resources.
Right. Yeah.
So like man in the middle attacks won't work basically, right? You can't listen into what we are talking. Right?
Yeah,
Yeah.
you can't. Man in the middle is an active attack, right?
Yeah. You have to
Is it? Okay.
identify like the two nodes and be in the middle of something.
Yeah, they need to perform a full man in the middle attack on the connection if they want to get a shared secret. So,
Right.
only thing this protects against is someone sitting there and doing nothing, not even running a node, just gets free access to all the packets you're sending over the network. Like they don't
Right.
have to consume any resources, like internet
Basically
service
an
provider,
ISP.
firewalls. Yeah, firewalls. They don't need to
Right.
do anything.
Hmm.
So this just prevents them from being able to use our data.
Makes sense. Okay. So this is what's gonna happen in the new case. And yeah, so after this is established, we do our usual workflow, and then nobody knows what we are talking about.
Yeah.
Cool, cool stuff.
Should we do? Yeah, we can do this in the next review club because
Yes,
we'll be
definitely.
looking into the code for that.
Yeah, we'll be looking more detailed about BIP324. So whoever here is like recommended to go through the BIP, go through the PR in more details, because next one we will be talking more about Alligator Swift, BIP324, Diffie-Hellman, key exchanges, and all the interesting stuffs.
Yeah.
Okay, cool. I guess like that covers all the questions we had for today's session. And yep, anybody has any further questions on this session? Basic of framework, testing framework, basics of V2, anything else? Cool. This was a good one, and yeah, this gives us a good, nice footing to start talking about V2 in more details. And thanks, Stratosphere, for all the work that went into this. This has been cooking for a long time and will be an amazing upgrade to Bitcoin Core. And thanks for explaining all these high-level stuffs to us and these amazing questions and notes. And yep, so this call is recorded. So look for the recording soon in our YouTube channel. And on the next one, we will also like announce soon the questions and the notes for the next session. That will be like the Thursday after next Thursday.
Yeah.
And we will carry on with the same discussion. Okay, thank you everybody for joining in. This is a wrap for today, and thank you, Stratosphere.